Okay, so today we are going to learn how to do inverse functions or finding an inverse of a function. So here we have f of x equals 3x plus 2. We want to figure out what the inverse of this function is. So when we're doing inverse, we are basically going to be doing 4 different steps to rewrite this in its inverse function. So the first step that we want to do, okay, so I've written the steps over here. There are 4 steps. First thing we're going to do is rewrite the function. And all we're going to do is replace f of x with y because y is just another name for f of x. So, let's see if this works. Okay, pause for the technical difficulties. Okay, so I think I got this figured out. We're going to replace f of x with y. They both are just outputs. And then the rest of it, like so. So this is step 1. You're just replacing f of x with y, which is rewriting your function. Step 2, so then step 1. In step 2, we are going to exchange x and y. So where y is, I'm going to put an x. And where x is, I'm going to put y. Very simple. So I've done step 2. And then step 3 is where we're going to solve for y. So we need to get y by itself. So in order to get y by itself, we want to look and see what is on the other side of the equal sign and what is going on. And we want to do PEMDAS backwards, right? So put a little reminder for PEMDAS. We want to do all grouping and exponents, parentheses, division bars first, then multiplication or division, and then adding or subtraction. So moving backwards when solving, we want to start here, right? We move this way. So we want to start with anything that is being added or subtracted to y. So I am adding 2, right? I'm not worried about the x because it is not on the same side as y. So since 2 is being added, I'm going to subtract 2 on both sides. And that is going to give me x minus 2 equals 3y, right? 2 minus 2 makes 0. I don't need to write plus 0 because that is the whole purpose of subtracting 2 is to move things away from y on this side. So next, now I have 3 times y, and the opposite of multiplying y would be dividing or multiplying 3 because I want to leave y by itself. So instead of multiplying this 3, if I divide this 3, that is going to leave 1y. And 1 times y is just y. But whatever I do to one side, I must do to the other. So now I have this x minus 2 divided by 3 equals y. Okay, so that now I am solved for y. I have y all by itself. And the very last step wants me to replace that, the y, and I'm just going to flip-flop them instead of having y last. So the f of x to the negative 1, this is the inverse. Anything to raise to negative 1 power means inverse. So the inverse of the function f of x equals x minus 2 over 3. And again, I'm just replacing y and f with this f of x to negative 1. So all I did was change that out for f of x to negative 1. But I did flip them instead of having the inverse written or the f of x behind here. So I flip-flop those, and then I switch that. But this is my answer. This is the inverse function of the function is up here. So there are your 4 steps. So let's do another one. Here we have f of x equals x squared plus 4. The first thing I want to do is change this f of x for y and keep everything else the same. Next, I want to flip or exchange y and x. So I want to change positions for y and x and keep everything else the same. Then I want to solve for y. And in order to solve for y, I want to do PEMDAS backwards. Just like we saw, whenever you solve an equation, you always work order of operations backwards. So I'm going to start with anything that's being added or subtracted to y, right? So y is being squared. That's the exponent that is going to come after doing anything adding or subtracting. So it is being added to 4. So if I want to add 4 to something, then I take that 4 away so that it doesn't have plus 4 anymore. So then I'm going to have x minus 4 equals y squared. Now, the exponent squaring something, the opposite of raising an exponent is doing a radical or taking the root of that same exponent. So since this is a square, I'm going to take the square root in order to undo this. So if I square root this, the square root and the 2 cancel each other out, and whatever I do to one side, I must do to the other side. So I have square root of x minus 4 equals y. Now I've solved for y. And if I want to just flip these so that I have what y equals, I would have y equals the square root of x minus 4. But we want to put this in function notation. So we replace y with f of x to the negative 1 power, which represents the function f of x inverse, equals the square root of x minus 4. And this, my friends, is our inverse function to the original function here.